Hello, this is Professor Bailey, and we're continuing our Essential Statistics material for elementary statistics at Dallas College. This is the lecture on Chapter 2.3, More Graphs for Quantitative Data. Again, I'm not going to speak to this slide, but it shows you what we're covering if you want to put it in your notes. Graphical summaries for small data sets. For small data sets, it's sometimes useful to have graphical summaries that are more detailed than histograms. In this section, some commonly used graphs that illustrate the shape of a data set while allowing every value in the data set to be seen. The first thing we're going to look at are stem and leaf plots. These are a simple way to display small data sets. In a stem and leaf plot, the rightmost digit is the leaf, and the remaining digits form the stem. You can see some values in yellow at the bottom of the screen, 14.8. The rightmost digit is the 8. Here, this is the leaf, and the rest of the digits, the 14, form the stem. On the second one, the data point is 2,739. Again, only the last digit is the leaf, and 273 form the stem. Let's look at an example that'll help make this more clear and so you can see the stem and leaf plot. The table below represents the U.S. Census Bureau projection for the percentage of the population age 65 by state. So we're going to construct a stem and leaf plot. This is a common example. Notice that all of the leaves, all the rightmost digits, are one decimal place. So they're the same decimal place. This is the kind of data that we typically use for a stem and leaf plot. So for Alabama, this stem is 14. For Alaska, it's 8. For Arizona, it's 13, etc. So when I plot these in here, what I'm going to do is I'm going to make a vertical list of all the stems in increasing order. So we have 8, 9, 10, all the way through 17. And then for each value in the data set, I'm going to write the leaf next to its stem. So for example, there was only one that had a stem of 8, and the leaf was 1. There was one data point that had a stem of 9, and its leaf was 0. There were 3 data points that had a stem of 10, and these are 7, 2, 5, etc. So what we do is we make this column of all the stems in numerical order, and then we just write each of the leaves to the right of that stem, and you'll see this vertical line here that separates the stems from the leaf. Once we've done that, we want to put each of the leaves in increasing order. And there you can see, so for like number 12, which had a lot of leaves, we just put them all in numerical order, and we count each one even if it's duplicated, just like we did for the stem 11. We can also do back-to-back stem and leaf plots. When two data sets have values similar enough so that the same stems can be used, their shapes can be compared with a back-to-back stem and leaf plot. We plot them the same way. Here we're looking at an example with course averages in English, which you see on the right side here, and course averages in history classes, and you can see those here. So when we're looking at this data, we can see that students tend to do better in a history class. Again, these represent grades 92, 97, 98 for history, and 91 for English. And so you can see the distribution of grades here, and it kind of gives us a lot better kind of a picture, if you will. It gives us a picture exactly. That's why we use graphs anyway, is that so we can turn numerical or quantitative data into a visual, which allows us, it actually helps us interpret the data or see patterns. And that's really what we're trying to do here, is see patterns. That when we just look at all these numbers, it's hard to pull a pattern, and especially difficult to compare the two. But when we look at it as a stem and leaf plot, we can see here that the history class is doing better than the English class. It's got a slightly higher average. Again, you can see where most of the grades are in the 80s for history and in the 70s for English. A dot plot is a graph that can be used to give a rough impression of the shape of a data set. It's useful when the data set is not too large and when there are some repeated values. Consider, consider the number of children had by each of the presidents of the United States and their wives. Okay. And so we can see here that there were 1, 2, 3, it's hard to see, 4, 5, 6 presidents who had 0 children. There were 2 presidents who had 1 child. I don't even know, I can't count that many because the dots are too small, but you get the idea here. So now we can see that the majority of presidents had between 2 and 4 children overall, and then we can see an outlier here that 1 president actually had 15 children. Again, it's a way to take all of this numerical data in a table and put it in some kind of visual form so we can see a pattern and notice those patterns. Remember, statistics is trying to help us make inferences or judgments or opinions about the data that we collect. And so when we put it into visual displays of graphs and plots, then it helps us kind of pull out those patterns, again, from a visual perspective, and it helps us understand the data better. The dot plot gives us a good indication of where the values are concentrated and where the gaps are. For example, it is immediately apparent that the most frequent number of children is 2. You can see that's the tallest number of dots, much like a bar graph, but each dot represents a data point. And only 4 presidents had more than 6 children. And here it actually gives the outlier. John Tyler was the president who holds the record so far. So again, each dot represents a single data point, and then you're just stacking them like dice or blocks, etc., over that data point. For example, in this one, the number of children. A time series plot may be used when the data consists of values measured at different points in time. In a time series plot, the horizontal axis, the x value, represents time, and the vertical axis represents the value of the variable we are measuring. The following table in time series, you see the graph, you see the graph at the bottom, and you see the table of values to the right. Again, when you're looking at these values of tables, it's hard to see a pattern. You can compare two numbers and see, for example, between 2005 it goes up, between 2007 and 2008 it goes down. But here we get a good, in the graph, in the time series plot, we get a good picture of the data over time and maximum values, minimum values, periods of time when it was decreasing, etc. This table and time series plot display the closing value of the Dow Jones Industrial Average. This is one of the measures on Wall Street from the end of the year 2005 to 2018. So here's a good place to hit pause. I'm not going to walk through this graph. In what year was the percentage the lowest? Okay, I'm sorry, I didn't even tell what this was. This is the percentage of high school seniors who smoked cigarettes every 2 years from 1994 through 2018. And again, overall, we can see the trend is going down, that less and less high school students are smoking cigarettes, specifically in this case, high school seniors. So in what year was the percentage the lowest? We can see that's the last year we recorded. What was the first year that the percentage was below 15%? What would we do? We'd go to 15, go across, and see where it hits 15 or is below. It looks like this is 15, so it would be the next year, which is between these 2 years, etc. So again, see if you can answer those questions. Hit pause. I didn't have a pause on this chart. I'm sorry I didn't have that. And see if you can answer these questions, and then they will pop up. When you finished answering them all, hit play again and you'll see the answers. Okay, obviously I just lied on that last slide. I'm not sure why the answers were not there. However, this is a table you can look at in your book, and so you can go back. It's a good we're early in the course, and so this is a good time for you to figure out how do you access the book. You can access the book in Alex. It's one on your page. You'll see a resource icon to the top right. You click on that resource icon and hit Alex Resources or McGraw-Hill Resources. One of those is the textbook. Sorry about that. Maybe that's why I didn't have a pause there. I wanted to include the table, but I forgot it didn't have the answers. As I mentioned in a previous slide, your textbook does a good job of explaining how to use technology, whether you're using a calculator, the TI-84, which is a recommended calculator for this class, or whether you're using Excel, which is something I highly recommend you doing, and you have specific problems for Excel in this class. And the reason I've included Excel as the main version of technology is that Excel is used extensively in business and technical careers. So if this is another place where you really want to go and look at your textbook at the end of each section where we're using technology to sort or measure the data or get data points that are statistical in nature, which we're going to look at in the next chapter, start looking at in the next chapter. Your textbook has a section at the end of each section that uses technology, and it explains step by step how to use those pieces. So if you want to create time plots with, in this case, with the TI-84 or with Excel, go to the section, go to the back of the section for this chapter, which is 2.3, and you'll see a page that's using technology. So this was a really short chapter. We were just looking at 3 different types of plots: stem and leaf, dot plots, and time series plots.